Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll be experimenting with yet another approach to data access organization, because there are a ton of them. So in the past episode, we used Mediator to segregate the use cases, as in the various operations of our application, in this case just in the group management API. In this one, we'll take a look at the data access organization that those use cases are making use of. You might have noticed that organization at a glance during that episode, but today we'll actually see the implementation. So we'll start with the idea behind it, the implementation regarding writing and then querying the database. We'll see some pros and cons of this approach, and take a look at saner approaches, because this one is very likely overkill, although I'm experimenting with things. Maybe eventually we'll get something more interesting. And as usual, the usual plugs. If the videos are being useful, consider liking them, sharing them, and leave feedback, being the last one the more important one, to help improve the videos, but the other ones also are pretty important to help grow the channel. And for more info, go to the blog. All the videos have an accompanying blog post. You can ask questions on the comments or even on Twitter. Or for other contacts, visit the blog or my personal website, where there are more social links and contact forms and stuff like that. With that out of the way, let's go. So, as usual, let me get back here. So let's start with the idea. As we saw in the other episode, we have the use cases, and then, for instance, in the create group, or maybe let's see the delete group, we have the logic over here. And what it does is it gets a iQuery handler of user group query group and a repository. So the repository is the same. You might know it. It's normally an abstraction to access the database, but in this case I tweaked it a bit. So this repository is only for writing, being it adding, updating, or deleting, and extracted the reading part, the querying part, out of it. And the querying part is done with these iQuery handlers, which are I define here, but are very similar to the iRequest handlers from Mediator. So if I take a look here, the compiling, so basically the same. So it's the same idea. And why is that? So basically, instead of having one repository and then having all the methods, which sometimes is what we do, we have a repository and then put all the methods that we want to be able to query the database. The problem with that is that we end up with a giant, we might end up with a giant repository class with a ton of methods, and we are always touching the same thing. So the idea here, like it was for the use case segregation, is to split the query logic across classes specific for each one. So it's exactly the same strategy. I could have also gone with that strategy for writing, but like this I already feel I'm going overkill. So if I even went this far, it's probably too much, but something to check out in the future, maybe. So this is the idea. We define a query handler, a query which takes the arguments that are required for the query. So in this case, we want to grab a user group. So what do we need? We need to know the user ID and the group ID. The group ID would be enough if we wanted just to get a group by ID, but in this case we want to make sure that we are grabbing a group for which that user has access. So user ID and group ID. So, and this part is on the domain layer or package. So I have giant letters for everyone to see well, but so in the domain, we have the use cases, and then I created this data part where I'm defining the interfaces. So I repository, I query handler. This interface is for that row version property I have in some places. I'm not a fan of using this interface, so maybe in the future I'll get rid of it. That's why I'm not giving it much importance. So we have here these interfaces. iQuery is just for the iQuery handler. So we must pass a type of query. And then we define the queries. So get user by ID, get user group, and get user groups, so all groups that the user belongs to. So in the domain, we define what we want, following that hexagonal architecture or onion or whatever that we talked in the past. The domain layer says, I need access to this, and someone will implement it in the infrastructure level. So just with this, we can implement this delete group, the create group. We go to the handler, it's the create only gets, just let me minimize this. Just gets a group repository and user by ID. So it needs to get the user to add it as creator, if I'm not mistaken. Current user, yeah, to put it as creator, so use it like this. So in the domain layer, we are abstracted to how we get that. We just know that we need that, and we know the data that is needed to do it. And now for implementation, we get rid of the domain and go to infrastructure, which is where we implement the actual part to go to the database. And in here, I follow this same organization. And here in the queries, I have, for instance, user by ID query handler. If you notice, this is pretty simple, and all of them will be kind of simple depending on the query complexity. So they require a dependency on DB context because we're implementing things using Entity Framework Core. And then handle async is just a matter of going to dbset, finding by ID, in this case user by ID. If we go to the implementation or user group query, again this part is exactly the same. And then in handle async, this is pretty big, but let me just put some enters in here. Okay, so in here, because the domain part has no idea how things are in the database regarding navigation properties and stuff like that. Okay, we are implementing everything, so we end up knowing, but ideally, in the perfect world, we would like to abstract all of that. So I'm not saying this does it, but it's a try. So in here in the handle, we go to groups, we do the include of the things we want, so creator, group users, and also include the users stuff, and then finally get the group user information, or the group information for the user that requested it. So, and the user must be part of the group, otherwise it's not going to return. It's like it's invisible for the user because he doesn't have access. So this is a slightly more complex query, but the logic is the same, even using this, because no need for much logic. And we can check out the other query, which is also similar, getting all the groups, including the creators, and all of that. So this is the implementation. If you already implemented stuff with Entity Framework or Entity Framework Core or any other ORM, this will seem similar. It's basically a repository with a single method each. and we can go, you can see the repository. I went with the classic EF repository name, and it's based on this GitHub project, eShop on Web, that I'll show you in a bit. But again, this is classic stuff. Add, you just adding to the set and save changes, update, also putting the entry in the context, checking the version. This part is needed because when we get the raw version coming from a request, but we got the entity from the database, we must override what's in the original values to be sure that the check will be made correctly. I think I talked about it in the episode regarding EF core, so 12 or 11. You can check it out if you want, or ask questions if you require. And then delete, also you just remove, and that's all. So the implementation is rather simple, and I'm not inventing something groundbreaking. Sorry. The only difference is really, instead of having everything in this repository or being a generic repository or stuff like that, I'm splitting things up. And then to use, you already saw, we just go to in the use cases, we declare what we require. So we require something that handles a query of this type and gives us a user. That's all for the usage. For registration, which might also be important in the web part, IOC, and somewhere here, one day I have to reorganize this because otherwise this file will be a disaster. So I'm using something that's called Scrutor. If I didn't use it, we would need to do something like this. So add individually all the repositories or all the query handlers by hand. So anytime we need it, we would need to add it like this. Instead, I'm using Scrutor, which is a, let me check Scrutor. So it's a NuGet package that helps us with doing things like this. For instance, other dependency injection containers have these capabilities, but the default Microsoft one doesn't. So we can use another dependency injection container or use Scrutor to build upon the default container. For now, I'm using the default container. So what this allows us is, instead of doing configuring the dependency injection for each one by hand, we can do something like this. In this case, we are scanning for services from the assembly of the DB context, which is the infrastructure, as we are doing add infrastructure, and then adding classes. So we're adding classes that are assignable to iRepository and assigning them as implemented interfaces. So automatically all the classes that implement this iRepository will be put here and injected and configured with iRepository of and the type. So we can then just declare in the constructors what we want. And here the same for iQuery handler. So anytime we create a new query in the domain layer and then implement it in the infrastructure layer, we don't need to go back to dependency injection configuration unless we require a new kind of dependency, because iRepositories and iQuery handlers will be registered automatically. Just one thing, just to be sure that everything is working as expected, I created here a unit test. Let me minimize this part. So in the infrastructure, I create here a query handler test, which what it does is goes to the assembly of iQuery, which is the domain assembly, gets all queries that are there, then grabs all query handlers, query handler implementations, and in the end it asserts that for all queries there are a query handler implemented. This is just to be sure that if I create a new query in the domain part, we don't forget to do the implementation in the infrastructure part. But not really needed, but just to keep some sanity. And I think I did the same for, let me check here, or not. But I could do the same for the use cases with Mediator. But because those are together in the domain layer, not as important. Okay, so I think for the implementation, it's basically it. It's not super complex. If you already learned about repositories and stuff like that, it's the same. I just felt like separating, and we'll see. I think it's now. So, pros and cons. So, not here. What would be the advantages of doing something like this? So, like I mentioned, for starters, is to avoid having a giant repository. Like using this common handler approach avoids us having giant services. This approach for the queries avoids us having giant repositories. So I prefer to have lots of classes and create a new class with new stuff instead of just adding more and more methods to the same place. Another thing, and what I feel is even better, at least for what I'm expecting to use, is if we want to unit test something like the common handler or something like that, if we have a repository with a bunch of methods and we want to mock it because we want to unit test this handler, we have some approaches. We can mock everything, which is annoying because it's not needed. Mock or fake or stub or whatever. We need to mock everything, which is not great because ideally we would like to have the tests as much, at least in my opinion, as much of a black box as possible. We just want to assert the result. We would like to avoid as much as possible seeing how things happen in there. So we can mock everything, or we can mock just what we need. And I think that by splitting things up and being explicit in what we need, so in this case, I need this query. To implement this use case, I need this query. Or maybe for another use case, I need this query, and this query. So it becomes explicit. We know exactly what we need to mock because it's explicit instead of just being a repository with 12 or 20 methods. We have one thing that we know we need to mock because it's on the constructor. And we know that because it's a single thing, it will be used unless the flow of the code doesn't reach that part. But besides that, it will be used. It's supposed to be used. So this is my main thing, the main two reasons. Avoiding giant classes, being able to create new classes to add more features instead of always touching the same ones, and much clearer dependencies. One thing I'm thinking about is instead of injecting an iQuery handler, just injecting a func that receives the thing, returns the thing. I think that's an interesting approach. Probably the code as it is will work, just need to make some tweaks to the dependency injection configuration to make this so it would seem like something like functional programming where we pass in functions that this code will call. So that's the main reasoning for me taking this approach. Now, of course, this has cons because, like you saw, I created a ton of classes that normally wouldn't be needed because if we just had a simple query, a simple repository with methods, we could just put their parameters instead of creating a class for the that represents the query and then another to implement the query handler and stuff like that. So it's more verbose, it's more classes, although I don't feel more classes is wrong if it minimizes giant files, but people might disagree. So this is the main reason for going with this, but I understand it's a bit overkill and some people will probably not be interested in going this far. So for more saner approaches to this, I have a couple. Yeah, can just show this working. If you notice, it's a bit different, the UI. I've been playing around with making it a bit prettier. I added a reference to Bulma. It's something like Bootstrap and stuff like that, because I have no skills to make this pretty, so this works as expected. So as expected, because I just split things up. But now let's look at saner approaches. The approach I was going to go initially, but then ended up trying to reinvent the wheel, was the one we can see here in the .NET eShop on Web reference application, which uses the repository, but uses like a generic repository with a thing they call the specification pattern, which is recommended by lots of people. If you see the blog of Ardalis, which is involved in this application, or Vladimir Korikov, if I'm not butchering his name, they recommend using this specification pattern. And what they do is, over here, they have the interface. So they have the, let's see, for instance, the repository, which has the get by ID, list all, and something that receives a specification. Then add, update, delete, count, stuff like that. So what does it do? So the thing is, this specification, if we go here, has a bunch of methods, and it's based on expression trees, which are used by ORMs. So by implementing this specification, they get something similar to the query or query handlers that I did, but with something I don't like. I like, but we'll see in a bit. So in here is specifications. Just want the basket with item specification, and implements that. And in the constructor, it passes in. So it has a base specification that implements all the things, and in the constructor, it passes in the expression. So to the query to do it, and the includes, stuff like that. So doing this part is done in the application core, so it's the equivalent of my domain. So you see the query is set up in the constructor, and it inherits from base specification, which implements those things with the includes strings, includes criteria, which is the way to filter, order by, all of that. So initially I was going to go with this approach. Why didn't I go with this approach? There's just one single thing I don't like. In general, I like it. The only thing is, even though this is generic, by using expression trees, we are assuming that we will use an ORM that uses them. That's why this works. If we go to the implementation, which is in the infrastructure part, there should be here a specification evaluator, which given the specification, does the matches what comes from the specification to the actual EF core implementation. So it is not tied to EF core, but it is tied to being used to an ORM within ORM that has this available. So it will work to EF core, it will probably work with EF and Hibernate and stuff like that. Why did I go with this? Because I'm expecting in the future in other services, probably not in the group management API, I'm expecting to use something like Dapper or just SQL or something like that, or even NoSQL databases, stuff like that. And if we go with this approach, the specification, it's tied to something that can use that. Otherwise, I would need to implement the link interpreter to translate those queries to whatever I'm using. And I don't want to do that because that's pretty complex. So that's why I went with that weird overkill approach. Now, I know this in most of the projects doesn't make too much sense, because you will use an ORM, so you can couple it a bit. So by using this approach is like this one in this eShop on Web, it's a nice middle ground between testability, because it's easier to test, at least I think it's easier to test things by using this repository pattern than using the EF core directly. But it's not as flexible as the other thing that I did. But as usual, it's a compromise. The thing I did is more flexible, but it's more complex. So this might be a good intermediate approach. So probably, if you ask me for a recommendation, I would say don't go so far as I did, unless you feel the advantages are really worth it. Otherwise, I say in most cases, probably this is a good approach. Another approach, which is the usual thing people complain about on the interwebs. So some people say you should use the repository. Other people say you shouldn't because EF core already implements the repository. So I'm not in it for the wars. So this is one approach. Another approach is just doing like Jimmy Bogart. And if you go here in the features, we can say courses. And then in the create, it just injects DB context directly and then uses it. And then it depends. You want to unit test this, you can use EF core in memory database. Maybe you prefer to not unit test, just do a lot of integration tests and just unit test specific classes. Depends on the approach. That's why I don't like when people start saying that their approach is better than the others. I think all are valid, just depends. So this one is much less verbose than this one, and even more than the thing I'm inventing or pretending to invent, because I'm pretty sure other people already did that, and in functional land probably they do it even better. Probably no, certainly. But these are just like 3 approaches, and there are probably more. One thing you don't want is to put SQL inside the domain logic. That I feel it's going too far, but besides that, you go with what you feel. But yeah, this approach is overkill, but I'm experimenting and trying out things. Let's see, probably I'll tweak things. I'm still not completely satisfied. I would like to reduce the verbosity and stuff like that, so I'll continue to play around, and probably there will be some tweaks in the future, but for now that's what it is. And if you want more sane and already proven approaches, you have these couple of examples and probably a lot more in the interwebs. So I think that's about it for this episode. So hope you enjoyed it. Again, like, share, feedback, stuff like that. And I hope to see you in the next one. See yous!